Well, hello everybody, and let us continue in Unit 6. And today we want to delve into a general type of reaction called redox, and several of the types that we've already learned, such as single replacement, combustion, are forms of redox reactions. So let us begin here. We have lead 2 oxide, solid, reacting with carbon monoxide to form lead, solid, and carbon dioxide gas. Is this a redox reaction? EGADS, new word, I'm not sure what to do. Of course, we have to go to notes, right? So we're talking about reactions, and we're talking about types. And one type of reaction that we have is called a redox. Now, a redox reaction includes some of our others, such as redox are single replacement reactions are redox. Combustion usually is a redox. Many, not all, synthesis reactions are redox. About the only ones that are not are most double replacement reactions are not redox. So we have redox reactions. And what is a redox reaction? This is AKA, also known as an oxidation reduction reaction. Okay, does that help any? Not a bit. I'm still confused. Okay, let's try to define this baby then. What is a redox reaction? It is a reaction in which electrons are transferred between reactants. Okay, reactants. Okay, so I understand that. I can understand electrons. So electrons are being transferred. And what does it mean? That means we have, to add more to this, it consists of two half reactions. So a half reaction. I'm not sure I know what that means. It must be a half a reaction. That's right. Consists of two half reactions. An oxidation half reaction and a reduction half reaction. Now, I wish I could learn more about this. What happens? Well, in an oxidation half reactions, a reactant, an atom in the reactants, an, an atom loses electrons. So we could have something like I have magnesium and it reacts and it's going to lose 2 electrons, let's say. And so what's formed? Magnesium 2 plus. So this would be an oxidation half reaction. Now, why is it only a half reaction? Because it doesn't show where those 2 electrons are going, for instance. Got it? And in reduction, what happens? Well, reduction is a case where an atom gains electrons. Cool. Okay, so I might have something like, let's say I have sulfur, and it's going to gain electrons. If it gains electrons, that means it's on the reactant side. It gains 2 electrons, and what's it going to form then? Sulfur minus 2, or sulfide. So that is my reduction half reaction. Now, notice if I put those two reactions together, I get magnesium, and I'm going to write all my things on the left side of the arrow together. 2 electrons. On the right side of the arrow, 2 electrons. And I get magnesium 2 plus and sulfur 2 minus. Good. And you notice I have electrons on both sides too, so I get rid of it. And so then I get this as my complete redox reaction. Hey, okay, cool, good. So let's go back then. And do we have enough to answer, is this a redox reaction? Well, I look at this and I really can't tell if are electrons going somewhere? I don't know. Well, we need another tool, and here's our tool. And we've already learned this, right? We've learned about oxidation numbers or oxidation states, right? We've learned about oxidation states, and what did I say the real purpose was? The purpose of these is for us to be able to identify redox. And how do we know that? Well, in oxidation, my oxidation number, my ox number of an atom increases. So if my oxidation number increases for an atom, then that species is oxidizing. Oxidizing. Good. And counter reverse of that, reducing. How do I recognize reducing? If the oxidation number of my atom decreases, then that is reducing. Okay, so now I know how to do this. I just have to find oxidation numbers. So here we go. I have PbO, that's an ionic compound. My oxygen is -2, which means my Pb must be +2. Here I have oxygen, that's -2. That means my carbon must be +2. On this side, what do I have? I have an element, meaning its oxidation number is 0. Cool. And what else? Over here I have 2-, and I have 2 of those. So my oxygen is 2-, but my carbon must be +4. Okay, so now let's figure out what is changing. Is my lead changing? Over here it is 2+, over here it is 0. So my lead is going from 2+ or +2 to 0. And what? My oxygen is 2-, 2-, 2-. No, my oxygen's not changing. What about my carbon? My carbon is 2+ here and 4+ there. That means my carbon is going from +2 to +4. Okay, now what's happening? I'm going from 2+ to 0. That means it is going down. My oxidation number is going down. When it goes down, that means it is reducing. So that means my lead is reducing. Pb is reducing. Good. Carbon, on the other hand, is going from +2 to +4. It is going up. That means my carbon is, when my oxidation number goes up, that is oxidizing. So my carbon is oxidizing. That means what? If it's reducing, what is happening to electrons? My lead is gaining electrons. If it is oxidizing, that means my carbon is losing electrons. Are electrons being transferred? Yeah, they're being transferred from my carbon to my lead. And that means, yes, indeed, this is a redox reaction. All right, you guys give this one a shot. Well, let's start here. I've got K. It's KCl. That is an ionic compound, so that means my K is a +1. My chlorine is a -1. Here's another ionic compound. The magnesium is easy. Magnesium is 2+ +2. Now I have NO3-, right? Okay, so my O's are -2, and that means my nitrogen must be +5. Okay, good. So we got that. We come over here. I have KNO3. My NO3 is still minus, and my K is a plus. So I have a +1 for my K, +5 for my nitrogen, -2 for my oxygen. And my magnesium is still +2. And my chlorine, I have 2 chlorines that have to be +2. So each chlorine is still -1. So what happened? -1 to -1, +1 to +1, +2 to +2, +5 to +5, -2 to -2. Did my oxidation states change? No change in oxidation state. So that means what? This is not redox, not redox. Now, you will see right away what's important. You must know your rules for oxidation numbers. If you don't know those, you won't be able to do these questions. Next. Okay, consider this. What element is reducing and what element is oxidizing? Hey, we've already done this, right? We did this up here. So, boy, we went through all of this and we said, what element is reducing? We said lead is its oxidation state went down. That means it is reducing. And carbon, so what is reducing? Lead. Why? Because its oxidation state went from +2 to 0. Carbon is oxidizing. Why? Because its oxidation state went from +2 to +4. When my oxidation state goes up, that is oxidation. When my oxidation state goes down, and I always remember this, right? Reducing means what? To go down. So when my oxidation state goes down, that is reducing. Good. And what's happening to electrons? How do I go from +2 to 0? Well, this guy gains 2 electrons. How does carbon go from +2 to +4? It loses 2 electrons. Got it. Hey, this is easy. Next. Okay. You guys try doing this one. Well, we start off here with sodium. Sodium here is an element. That means its oxidation state is 0. Oxygen is -2. My hydrogens are +1. Now I have an ionic compound here. So that means I have an ion formed between Na plus and OH minus. So what is the oxidation state of Na plus? +1. My oxygen is -2. My hydrogen is +1. Here, what do I have? That's a diatomic element, meaning it is 0. Okay, so what's changing? My sodium starts out at 0 and goes to +1. So sodium is going from 0 to +1. What else is changing? Well, oxygen is -2 here. Oxygen is -2 there. Okay, it's not oxygen. Hydrogen is +1 here and +1 here. Oh, here it's 0. So that means hydrogen is going from +1 to 0. Okay, so here my oxidation state goes up. Here my oxidation state goes down. If my oxidation state is going down, that means it is reducing. If it is reducing, it is gaining electrons. And the opposite has to be true for sodium. If it's going up, it must be oxidizing. And if it's oxidizing, it is losing electrons. There we go. So what is oxidizing? Sodium is oxidizing. What is reducing? Hydrogen is reducing. All right. How many of you got that right? Good, good, good. Ooh, what is the oxidizing agent? Ay, caramba. And reducing agent. We got some new words here, don't we? We have some new words. That means we must have some new notes. All right. Now we have here in redox. And I need a line, a super line to cut through everything. It's going to have to come through and jump over there. And we get to this open space, and we want to talk about agents. Agents. Secret agents. Dun, dun, dun. Secret agents. What kind of agents we can have? We can have oxidizing agents, and we can have reducing agents. Na, 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 na. Good. Oxidizing agents. Well, what's an oxidizing agent? It is a reactant. Notice we're not saying anything. It is a reactant. It is a reactant. That means it's on the left side of my yield arrow, which causes something else to oxidize. Well, if it's causing something else to oxidize, that means it's making something else do what? Lose electrons. How's it going to do that? Well, something in the reactant, meaning one of the species, one of the atoms in the reactant, is gaining electrons, meaning it is reducing. Okay, so something in that reactant is reducing, and that means it's forcing the other reactant to oxidize. Okay, cool. And now what are some typical oxidizing agents? Permanganate is a big oxidizing agent. Dichromate is a big oxidizing agent. Fluorine is a big oxidizing agent. These guys love to gain electrons, and that makes something else reduce. Good. So what are my reducing agents? Excuse me. These guys love to gain electrons, which force something else to oxidize. Have to get that right, right? Oxidizing agents cause something else, meaning another reactant, to oxidize. Reducing agents, it is a reactant which causes another substance to do what? To reduce. And if that's causing something else to reduce, that means some atom in this reactant, in the, let's call this, in the oxidizing agent. Something in the reducing agent is oxidizing. You got that? If I make something else reduce, how about reduce? To reduce, there we go. If I make something else reduce, remember, reducing means gaining electrons. That means something else. If I cause that to happen, I must be doing what? Losing electrons, and losing electrons is oxidizing. Okay, you guys got that? I hope you do. Metals tend to be very good reducing agents. All right, so let's see if we can do this. I know it may be a little foggy right now, but let's give it a shot. First thing we want to do is figure out what's happening here. My hydrogens are +1. I have 4 of them. That means my carbon is -4. This is oxygen as a element, so that's 0. Here I have 2 oxygens. That means that's -2. And if I have 2 of them, the carbon must be +4. Here I have -2 and +1. So what's changing? My carbon starts out at -4 and goes to what? My carbon goes from -4 to +4. Okay, so that means it's going up, so that means that is oxidizing. What must be causing it to oxidize? Well, here it is. My carbon is in methane. That is oxidizing. That means something else must be causing it to oxidize. Well, what's my other reactant? Oxygen. And what is oxygen doing? It's going from 0 to over here and here. It's going from 0 to 2 minus. So that means oxygen is reducing. Okay, good. So we've got that. So what's causing my carbon to oxidize? Well, the oxygen atoms. So that means not oxygen is my oxidizing agent, but O2. It has to be the complete reactant is the oxidizing agent. Remember, an agent causes someone else to do that. So oxygen is not oxidizing. Oxygen is causing carbon to oxidize. What is oxygen itself doing? It is reducing. What is causing that to happen? Well, my carbon is oxidizing. The reactant in which carbon sits is methane, which means that methane is my reducing agent. Okay, not that difficult. It sounds difficult, but it's not. Here we go. A couple more. You guys give this one a shot. Well, start off here. K is 0. Magnesium is +2. My chlorines are -1. My K in the compound is +1. Chlorine is -1. Magnesium is 0. So what is changing? Potassium is going from 0 to what? +1. That means it is oxidizing. Oxidizing. It is oxidizing. What must be causing it to oxidize? Well, potassium doesn't cause itself, so that means magnesium chloride is the oxidizing agent. Good. Now what is reducing? Magnesium is going from +2 to 0. So that means it is reducing. Magnesium is reducing. What is causing magnesium to reduce? Well, K is the reducing agent. All right. No problem there, is there? Okay. Lastly, let's look at potassium and dichromate. Which is the stronger oxidizing agent? Aha, we've already gone through that. Let's go back and take a look at our notes for a second. I said, what are some really big, important oxidizing agents? Permanganate, dichromate, fluorine, right here. Dichromate is a important oxidizing agent. So you just memorize that. We come back here. Which of these is an oxidizing agent? Dichromate is the stronger oxidizing agent, and potassium really is a what? Reducing agent. Okay, that's all you need to know about the basics of redox. Next time, I'm going to teach you a very complicated method of balancing redox. And I'm not kidding. It's a whole bunch of rules, like 10. But if you follow them, you'll get it right. And if you don't, then you'll probably get it wrong. So next time, be ready to learn some steps in balancing redox. Auf Wiedersehen.